Okay, I'm going to try to go over the review sheet with you. If you guys still have questions, please email me and I can try to clarify some things. For number one, you are writing this as a conditional. The little circle that is inside, so the like subset squares, that's your hypothesis. And then this part is your conclusion. So you're going to say something like if squares, then quadrilaterals. So to make that make more sense, we can say if a figure is a square, then the figure is a quadrilateral. Okay. For number two, you're just going to identify the hypothesis and conclusion. So what I want you to do is single underline hypothesis and then double underline conclusion. Or you could use like colors if you want. So you could maybe like underline conclusion and pink, and then you can underline hypothesis and orange or something like that. So it says if a number is a whole number, then it is a non-negative integer. So remember with hypothesis, the hypothesis is everything that comes after the if. So a number is a whole number is the hypothesis. And then the conclusion is everything that comes after the then. So that would be it is a non-negative integer. So for the second one, it says if a student goes to UCF for college, then the student made the right choice. A student goes to UCF for college is the hypothesis. The student made the right choice is the conclusion. Oh, you know what? I just realized that I underlined those in the wrong colors. My bad. Hypothesis, conclusion. I totally underlined those in the wrong colors. Okay, so this is the hypothesis. This is the conclusion. All right, so pink is hypothesis, orange is conclusion. Pink is P, conclusion is Q. Okay. Determine if the conditional is true or false, and if it's false, state a counterexample. So if it's not false, don't state a counterexample. If an angle is obtuse, then its measure is 150 degrees. Okay, well, if it's obtuse, that just means it's greater than 90 and less than 180. So a counterexample, so this would be false, because they're not all 150. So a counterexample would be the measure of an angle is maybe 170 degrees. Okay. Or you could write those words too. You could write the measure of an angle is 170 degrees. If two negative integers are added, the sum will be positive. Okay, so two negative integers. For example, like -1 plus -3. So when you add those, is that positive? No, it's negative. So you would say false. And then that could be your counterexample. -1 plus -3 is -4. It's not positive. That's a counterexample. Now, if it's true, you'll just write true. Okay, write the statement as a biconditional if possible. So some of these will be possible, some of these won't. If it's possible, then the conditional and its converse will both be true. So it says, if you are an athlete, then you play soccer. Okay, so is that true? So right off the bat, are there other athletes that play soccer? That don't play soccer? Yes, there are plenty of athletes that don't play soccer. So this conditional isn't even true. If the conditional is not even true, you can't possibly write a biconditional. So that one's not possible. Now B is a little bit more complicated. So for B, you might want to write the conditional and the converse and then see if you can write the biconditional. So it says the integers are the whole numbers and their opposites. So integers whole numbers and their opposites. Integers would kind of be like a hypothesis, and then whole numbers and their opposites would be the conclusion. So you can say if a number is an integer, then it is a whole number or its opposite. That would be a conditional. Okay. This is true. The converse of this would be if a number is a whole number or its opposite, then it is an integer. So if a number is a whole number or one of its opposites, then it is an integer. That is also true. Okay, so if both of those are true, we can write this as a biconditional. So the biconditional, which is your final answer, would be numbers are integers, and then the key words here for biconditional are if and only if they are whole numbers and their opposites. Okay, so remember, for a biconditional, it has to have the if and only if in it. That's what makes it a biconditional. If it doesn't have that, it's not a biconditional. If you can't write it as a biconditional, you just write not possible. Okay, for 5, we're using the law of syllogism to make a conclusion. I'm going to color code a bit. So the hypothesis of the first statement, it says if a number is a whole number. So a number is a whole number would be the hypothesis. And then the conclusion of that statement would be it is an integer. The hypothesis of the second statement would say if a number is an integer, so a number is an integer would be the hypothesis. And then it says then it is a rational number. So it is a rational number would be the conclusion of the second statement. So using the law of syllogism, we should say if a number is a whole number, then it is a rational number. Okay, so the law of syllogism takes the hypothesis from the first statement and links it or makes it conditional with the conclusion of the second statement, as long as the conclusion of the first statement is also the hypothesis of the second statement. So if these two are not the same color, it doesn't work. Okay, let's look at the next one. If a shape is a square, so a shape is a square is your hypothesis, then it has 4 sides. So it has 4 sides is your conclusion. If a shape has 4 sides, okay, then it is a quadrilateral. So it is a quadrilateral would be your conclusion. All right, so as long as these two are the same color, so this is Q, then we can make a conclusion. If a shape is a square, abbreviating a little bit, then it is a quadrilateral. Okay, so if a shape is a square, then it is a quadrilateral. Now the law of detachment is different. It says if P implies Q is true and then P is true, then Q has to be true. So if 2 angles are vertical, 2 angles are vertical would be the hypothesis. Then they are congruent. So they are congruent would be the conclusion. Angle ABC and angle XBY are vertical. So it's talking about vertical angles. That means this is a type of P. So what we have is P implies Q is true. They give us a P. Then we can conclude Q from this statement. So we can say angle ABC and angle XBY are congruent. For the second one, it says, if you play soccer, then you are an athlete. So you play soccer would be the hypothesis. You are an athlete would be the conclusion. It says Alex is an athlete. The blue is P. The pink is Q. This is a type of Q. The law of detachment doesn't say that we can make a conclusion here. And the reason for that is because Alex is an athlete doesn't necessarily mean he plays soccer. He could play anything else. Tennis, he could play football, he could play anything else. That's an athletic thing, but not necessarily soccer. So for this one, we're going to write no conclusion possible, because it does say make a conclusion if possible. So if it's not possible, you're just going to write not possible or no conclusion. For the next example, we are filling out this chart. So we need to find the inverse, converse, and contrapositive of this statement. If an integer ends in 0, then it's divisible by 2. In this statement, an integer ends with 0 would be the hypothesis. It is divisible by 2 would be the conclusion. So to find the inverse is the negation of P followed by the negation of Q. So make sure you know what all these words mean: inverse, converse, contrapositive, conditional, etc. So we're going to negate P. This is P. This is Q. So if an integer does not end with 0, then it is not divisible by 2. So we negated the hypothesis and we negated the conclusion by adding the does not and is not. Okay, so let's read this and see if it's true or false. If an integer does not end in 0, then it's not divisible by 2. So things that don't end in 0 are like 13, 14, 15, 16, random numbers. Now, 14 doesn't end in 0, but it is divisible by 2, so that means this is false. It doesn't say to provide a counterexample, but if you were to provide a counterexample, 14 would be a good one. So would 2 or 28. Okay, converse. So for the converse, all you're doing is switching the conclusion with the hypothesis. So we can say, if an integer is divisible by 2, then it ends with 0. So is that true? Are all integers that are divisible by 2, do they end with 0? No. We were just talking about a few that don't, like 14 or 28 or 16. Those divide 2, but they don't end in 0. Okay, so finally the contrapositive, which kind of puts the inverse and the inverse and the converse together. We're going to negate Q, negate P, and then switch them. So if an integer is not divisible by 2, then it does not end with 0. So remember those nots are in there because we're negating them, and we switched the conclusion, so pink, with the hypothesis, blue. Okay, so if it's not divisible by 2, then it's not going to end in 0. So things that don't end, or things that are not divisible by 2 are like 3 and 5, like all odd numbers are not divisible by 2. Are there any odd numbers that end in 0? No, so this is true. Okay. All right, next question. We are going to find angle COA and then justify our steps. So first I'm going to just plug in what it says. It says COA is x plus 10, and then BOD is 4x minus 35. So one thing that you should note from the picture is that these two angles are vertical angles. Okay? and vertical angles are congruent by the vertical angle theorem. So we're going to say angle COA is congruent to angle BOD. And we know that by the vertical angle theorem, which you can abbreviate as VAT. Okay, then we're going to say that the measure of COA equals the measure of BOD. Okay, we know that because angles that are congruent have equal measure. That's called the definition of congruence. Once we go from our congruent statement to an equation, we can start substituting in things. So we'll start plugging in x plus 10 and 4x minus 35 for those two angles. That's substitution. Now I need to solve this equation. So one way I can solve is I can subtract x from both sides. That would be the subtraction property of equality. After that, I would add 35. That would be the addition property of equality. And then I can divide by 3. That's the division property of equality. We would be done, but it didn't ask for just x. It asked us to find the measure of COA. This is COA right here. So I'm going to finish it by saying that the measure of angle COA is equal to x, which is 15, plus 10. So 15 plus 10 is 25. So 25 degrees. Make sure you put degrees. And this is just substitution again. For number 9, we are also finding x and justifying each step. So for this one, it's a segment, not an angle. So we have a bunch of little segments, and they all have different labels. So this piece is x minus 6, this is 9, 2x minus 19. The whole thing is 23. So we know that when we take this piece, and this piece, we can add up those pieces to get the long piece. So that's going to be the first thing I write down. I'm going to write NM plus ML plus LK equals NK. That reason is the segment addition postulate. So remember, there's a segment addition postulate and there's an angle addition postulate. Okay, next we will substitute in the values. We have x minus 6 for NM, we have 9 for ML, we have 2x minus 19 for LK, and we have 23 for the whole thing NK. That's substitution. All right, we can combine like terms over here. So for example, we can combine x and 2x. That'll give us 3x. We can also combine negative 6 and 9. That's going to make 3. 3 plus negative 19 is negative 16. So that's combining like terms. Then we have to solve the equation more. So we would probably add 16. So 16 plus 23 is 39. And since we added 16 to both sides, that's the addition property of equality. Then we divide by 3 and get 13. And that would be the division property of equality. Okay, and then what you should do is you should take 13 and substitute it back in and make sure that it makes sense. So, for example, if we take 13 and we plug it in right here, 13 minus 6 is 7. If we take 13 and we put it here, we get 26 minus 19. Sorry. So if we take 13 and we put it here, we would get 26 minus 19, which is also 7. And then when we add these up, we should get 23. So 7 plus 9 is 16, plus another 7 is going to be our 23. So that shows that we did it correctly. Okay, and finally we have one more question about supplementary angles. So it says CDE and EDF are supplementary. We know that the word supplementary means the measures of the angles should add up to 180. So that's going to be the first thing we say. Measure of CDE plus the measure of angle EDF equals 180 degrees. This is the definition of supplementary angles. Then we will substitute x and 3x plus 20 into the measure of CDE and the measure of EDF. I can combine like terms again and get 4x plus 20 equals 180. And then you should subtract 20 from both sides. That's the subtraction property of equality. And then divide by 4, and you get 40. That's the division property of equality. So abbreviating a little extra at the end there. And then again, you should be able to take 40 and plug it back in. So let's do that real quick. So measure of CDE, if you plug that into x, you just get 40. If you plug in 40 into EDF, you get 3 times 40, which is 120, plus 20 is 140. So you just want to make sure that these are supplementary, and they are. So that's good. That means you did it correctly. Okay, so again, make sure you email me if you have questions, and remember to look over the vocab from Chapter 1 specifically if you didn't do so great on that. And I hope to see you guys soon. Bye.